Hey everybody, we're at video 3 for standard 3. I'm still working on graphing and trying to find some key characteristics. And we've talked a lot about finding intercepts and discussing where it crosses the x-axis. But what if those places aren't integers and they're not really the nicest of numbers? So we're going to use our graphing calculators this time. So make sure that you have your graphing calculator ready to go with you because I'm going to give you some different buttons to press. So not only are we going to talk about finding the zeros using our graphing calculator, we're also going to be talking about something called turning points. And that's a new concept. So this video really has two examples, but we're going to find two different things for each of those examples. And you do need your graphing calculators with you. So let's go ahead and get started. So I want you to start by entering this polynomial into your graphing calculator. So you may need to pause the video to do that, but please enter 2x cubed minus 9x squared plus x plus 20 into your graphing calculator now. All right, then you should be able to graph it and see this picture, and you need to make sure that the zeros are in the window, as in that all the x-intercepts are within range of you seeing them on the screen. So you don't want anything to be way off at like -11. You would need to then zoom out or change your window so you can see everything. But here it looks like if you've got, remember you can always use zoom and then the 6 button to get to the regular standard 10 by 10 screen. But this is what it looks like. And the next thing we're going to do is we're going to go ahead to what the calc menu is. And that button is the second trace. It's above the arrows and it says calc. So press second calc once you've got all of this ready to go. And what you're going to choose is the second option. The second option under second calc is 0. Okay, and zeros are our x-intercepts, so let's keep that in mind, our x-intercepts. And when you press that, it takes you back to the graph. And it's going to ask you 3 questions. You'll see those questions at the bottom of your screen. The questions are left bound, question mark, right bound, and guess. So you may choose to use the arrows, the left and right arrow keys, to move the little cursor, which it's kind of like your little frogger that kind of has to move along the curve. You can move them left and right if you want. So I'm going to use this graph over here. If you move it all the way to the left, you want to position it below the x-axis. And then you want to position it above the x-axis. And what you're doing is you're helping the calculator with the intermediate value theorem, saying there has to be a 0 here because I'm below and I'm above. Okay, but it has to be on the left and on the right. So this would be the left bound and this would be the right bound. Or you can say, well, I'm pretty sure if you go to -2, and you can just type in -2 for the left bound, and you're saying that's somewhere over here. And then you type in a right bound, which maybe I'll say, oh, I think my right bound is -1, as in it's between -2 and -1. You're guiding the calculator for the intermediate value theorem. The last thing I want you to do is guess. And you don't really have to make a guess at all. You can just press enter and let the calculator do it. Or if you want to, I can say, well, it's -1.2. And it will do the guessing or do all the work for you. And it did come up to be approximately -1.2. And this is what it shows on the bottom of my screen. So let's do the next one. So I see the next one has to be between 2 and 3, which means my left bound is the 2 and my right bound is the 3. So the left and right switch as to which is on the left, is it above and below. So let's press second calc again. You want to go to option number 2. And you can arrow over and place the little cursor on the left side, which in this case would be above, which maybe I would say my left bound is 2. And then my right bound has to be something like 2.5 or 3. And when you guess, It does produce this second zero, which is 2.1933. The last one, so let's try that one, second calc, and you go to the 0 option. And again, if you're using the cursor and you're arrowing left and right, this time the left bound is below and the right bound is above. Press enter when you get to the left bound and press enter on the right bound. Or for the left bound, you can type in the number, maybe you want to type in the number 3 and 4, so that would be your left and your right. You can type those numbers in. And when you guess, it gives you approximately 3.5801. So this is how we could use the graphing calculator to find zeros that aren't going to turn out so nicely. They're not something that I would be able to factor and find. They're not something I would be able to use synthetic division necessarily and find, because the zeros themselves are irrational. All right, so let's go on to the next thing we're going to do on the calculator. All right. So we're going to be looking for turning points here, and turning points, we're going to use the same function, so I'm keeping the same function there. But turning points are finding where the graph turns direction. And this happens when you reach a maximum, a height, and then it starts diving back down, or when you hit the bottom, like a minimum, and it starts shooting back up. So these are called turning points, otherwise known as maximums and minimums. But it is a change in direction. It's actually a change in the increasing and decreasing, and you'll see that. So maximum, this is an important thing, so I want you to kind of circle this or highlight it or something, because the maximum number of turning points that we can possibly find is one less than the degree. So if I have a x squared, then I can only have one turning point. If I have an x cubed, I can only have a maximum of 2 turning points. This doesn't mean I must have 2, but it's the maximum number that I could have. If I have an x to the 4th, the most I could have is 3 turning points, and so on. So it's one less than the degree. And I want you to think about a parabola. How many times does a parabola change directions? It changes once, okay? My x cubed graphs, we've looked at a few of those where they've changed more than once. They've changed twice. They go up, they come down, they go back up. Or they have that kind of swerve in the middle, which means they really don't have any turning points at all. So we're going to go ahead and look at this graph and discuss the turning points. So we're going to start with the graph. You've got that on your screen, and we're still going to go back to that calc menu, but this time we're going to be looking at either the maximum or the minimum, which is numbers 3 and number 4. So go back to the calc button, and I'm going to select the minimum first. Okay. So when I select the minimum, I have to address the minimum, and that would be this one right here. So I don't want to address the maximum, which I actually can't even see right now in my calculator at all. But addressing the minimum, it's going to again ask me for a left bound and a right bound. So my left will be on the left of the minimum, and my right will be on the right. And I do recommend just using the arrows and moving over. You do not have to be above or below any sort of axis. You just have to be on the left side of the minimum and then the right side of the minimum. So once you get to the left side, press enter, and then it asks you for the right bound. So arrow over until you're on the right side of it. And then when you're done, press enter on the guess, and it produced a minimum value. So it's actually telling you where the lowest point that you indicated is. So if there's more than one minimum, we would have to do this more than one time. So there's our minimum. Now for our maximum, I can tell that this graph is going to go as high as 20 and maybe higher, because it crosses the y-axis at 0, 20. So I'm going to first change my window before I find the maximum. So go to your window, and let's change our y maximum up to 30. So let's go above where we think it's going to be. And then press graph and see it redraw it and see if we went high enough that we could now see the maximum value. And we sure can. All right, so once you've got your graph up, we're going to go back to the Calc menu. We're going to select the maximum this time. And we're going to be on the left side of the maximum. Press Enter. And then arrow over to the right side of the maximum and press Enter. And if you'd like to arrow in the middle and guess, that's fine. And you end up with this being our maximum value, as in the highest value. Now your decimals may be slightly off, and that's just based on the rounding of the calculator and the accuracy in which you narrowed down the space. If you're very off to the left or very far off to the right, you're not helping the calculator very much, so your approximation is not as accurate. All right, we're going to try one more example together. Remembering where we can find this information. So here's our second one. So take a moment if you need to pause the video and type that into y equals. Once you've got it graphed, you'll recognize that you probably can go back and do zoom 6 so you can see just the normal picture of this one, because it does fall right nice and neat in between everything we need it to. And we're going to find the zeros first. And I first want to say, well, how many zeros do I think I'm going to find? And I believe I'm going to find 4 zeros. I see that this crosses 4 times. So I will repeat this process 4 times to find those zeros, choosing left and right bounds. I would like you to pause the video and try this on your own. So I'm going to, in a couple seconds after I stop speaking, I'm going to start again, but with the answers. So I need you to pause and give it a try to find the zeros, and then we can discuss if there was any issues in finding them. Okay, so I'll go ahead and pause now. All right, so I have found all of the zeros, and we will probably want to discuss as a class how many decimal places are appropriate to round to. So let's hold off on that conversation until we're all together. But these were the zeros that I was able to approximate using the second Calc zero feature. So if you did not get one of those, or if you were off quite a bit on the rounding, just go ahead and make a note to yourself, and we will talk about that when we're together again, so we can do it in person. Now, if you got nowhere near these, do go back and make sure that you at least typed the function correctly, and that wasn't the mistake from the beginning. So now we're going to find the maximums and minimums. Now I'm going to do a quick sketch so we can see what this sort of looks like. It looks like it goes, let's see, there's there, and there, and it goes down here, up, and down some more. Okay, so it looks sort of like this. So that means I'm going to find 2 minimum values and 1 maximum value. So I've got minimums and I'm going to get a maximum. So once again, I'm going to ask you to pause the video here in a second, and I want you to find the minimums and maximums using that second Calc min and max feature, choosing your left and right bounds, and then unpause it when you're ready and we can check our answers together. So go ahead now. All right, so these were my minimums, my 2 minimums and my 1 maximum. If you were struggling to find these, make sure that you chose the left as the left. Sometimes we get carried away, and if we would choose the right side and make it the left, and then it doesn't know how to calculate for us. So your left bound must legitimately be on the left side, and your right bound must be on the right side. So there's one thing that may have gone wrong. And otherwise, we will talk about the rounding together. So write down any questions that you have and any struggles or errors that you've gotten, or even take a picture of your calculator screen so we can address the specific error that you may have run into. Hopefully all was successful, but we will discuss this more when we're together in class. Great job.